Hey everybody, this is Mr. Beckstrom, and today I want to work a problem from section 6.3. It says find the exact value of each of the remaining trigonometric functions of theta. So remember we have 6 trigonometric functions, so I'm going to go ahead and just write them all down here, and then we'll find them all. So we've got the sine of theta, the cosine of theta, the tangent of theta. I'll even write down the cosecant of theta. I was going to say the secant. It's already there, so we know what that one is already. That one is equal to 9. And the cotangent of theta, oops, of theta. Oh, I just messed this up. Hold on just a minute here. I got it. And the cotangent of theta, so that should be all 6 there. Okay. Alright, so right away, if the secant is equal to 9, I know that the secant is defined as 1 over cosine, so I can just take the reciprocal of 9, so I know cosine is just 1 over 9. So that's an easy one, but the rest of them are going to be a little bit more difficult. So let's go ahead and figure out one of the ways we can solve this. Now there's multiple ways we can do it. I think if you look in the example help in my math lab, it will use the Pythagorean theorem to help us, which I think we're actually going to use part of that, but maybe not in the exact same way that they do it. But here's how I would look at it. So the first thing I would do is I like to see which quadrant we're in, and this and this both give us clues. The first one kind of narrows it down to the 2 quadrants, and then this last one will narrow it down to 1 quadrant. So the secant, which is, remember, related to the cosine, is positive. So the cosine is positive in the first and the 4th quadrants, right? Because that's the x value. So it's positive in these 2 quadrants. And then out of those 2 quadrants, the cotangent, which is related to the tangent, is only positive in the 1st quadrant there. So this is the quadrant that we are talking about. So you look to see if it's positive here. It has to be in these 2 because that's where the x value, which the secant refers to, the secant and the cosine refer to the x value. And then the cotangent, which is the y value divided by the x value, is the x value divided by the y value, is only positive in the 1st and the 3rd quadrant. But since we have already eliminated the 3rd quadrant, then we're only talking about the 1st quadrant there. All right. So that means that we're in the 1st quadrant here. So I'm going to go ahead, draw my angle. That was not a very straight angle. Let me try to draw a little bit straighter of an angle if I can. All right, pretend that's a straight angle there. Well, okay, one last try here. All right, and I'm going to draw a nice little right triangle. I'm going to create my theta coming out of the central angle there. And now this is the secant. Now remember, I already know what the cosine is, and the cosine, if we remember from SOHCAHTOA, is adjacent over hypotenuse. So this would be the adjacent side, so that would be 1 over the hypotenuse, which would be 9. So the only remaining side here I would need to find is this opposite side, which then I could use the Pythagorean theorem. So I know 1 squared plus my remaining side squared, right, is equal to 9 squared. 9 squared, just like this. right? Because, all right, and then so x squared is equal to 81 minus 1, which is 80. So x is equal to the square root of 80. And that can be simplified down to, let's see, we can pull a 16 times 5, so that would be 4 root 5. So that would be 4 times the square root of 5. Remember, for a little refresher for some of you who forgot, we can take the product of the largest perfect square factor of 80, which happens to be 16. And so it's 16 times 5. And we can take the square root of 16, which is 4, and pull that out. And then we're just left with the 5 there. All right, so this side over here is 4 times root 5. And that's all the hard work, or the heavy lifting, as you might put it. And the rest is pretty much just using kind of SOHCAHTOA to do the rest of it. Now we're in the first quadrant, so everything's going to be positive, so I don't have to worry about any negatives. So I'm going to go ahead and write out SOHCAHTOA. And let me make this a little bit bigger so I can see it there. Okay, so let's do the regular trig functions first. So the sine is going to be opposite over hypotenuse. So that one's going to be, oh, I almost moved that whole thing there. So the sine is going to be 4 root 5 over 9. 4 times the square root of 5 over 9. All right, that means that the cosecant is going to be just the reciprocal of that. So 9 over 4 times the square root of 5, which we can multiply both the top and the bottom by the square root of 5 to rationalize the denominator. So that'll be 9 times the square root of 5 over 20. 9 times the square root of 5 all over 4 times 5, which is 20. So if we want to rationalize the denominator, we can do that. All right, so that is sine and cosecant. And then last would be tangent and cotangent. So tangent is opposite over adjacent. So that would be 4 root 5 over 1, or just 4 root 5. 4 times the square root of 5. And then this would just be 1 over 4 times the square root of 5. These would be adjacent over opposite. And once again, we could multiply both the top and the bottom by the square root of 5, which would give us the square root of 5, square root of 5 over 20. And there would be your 6 answers there. All right, if you all have any questions, please let me know. And I hope you have a great rest of your week. Thanks.